In this video, I'll show you how to add two hydroxy groups to an entire addition. That means two groups will be adding on two different sides. Now we have our alkene and we have our peroxy acid that reacts with each other, forms an epoxide that is nothing but a cyclic ether, undergoes acid catalysis and forms two different enantiomers. Now we have two common examples of peroxy acids here. And the second one here is called MCPBA, or metachloroperbenzoic acid, that is widely used peroxy acid. Now, the mechanism it undergoes is called a concerted mechanism. That means all the electrons are moving at the same time in the cycle. And you'll be seeing that a moment later. Now, the mechanism here that we have our alkene that has pi bond. So it will add the oxygen atom here. As a result, we'll create a partial positive charge at this carbon, and so this lone pair of electron of the oxygen will also add this carbon atom. As a result, the electrons of this bond will no longer be wanting to be with this oxygen atom, so they will try to be collapsing on this oxygen atom, but rather they will move towards this particular bond here. As we have another pi bond here, so this electron will try to move on to this oxygen atom, but rather it will attack this hydrogen atom, but hydrogen atom cannot have more than one bond, so the electrons of this particular bond will be going on to this oxygen atom as a lone pair of electron. So we'll form an epoxide here and we'll be living with an organic acid. Now we have our epoxide here and this is our acid catalyst. So this lone pair of electron will attack this hydrogen atom. That means the electrons of this bond will be moving on to this oxygen atom and we'll be living with water and will form a bond between oxygen and hydrogen, leaving a positive charge onto the oxygen atom. Now, this lone pair of electron of this oxygen will attack from the backside through SN2 mechanism, so will form a bond. Here you can clearly see with the water molecule and this carbon atom. So later on, we'll try to deprotonate one of the hydrogens of this water molecule. So our lone pair of electron of this oxygen atom will attack this hydrogen atom here. That means it will leave the electrons of this bond on this oxygen atom. So our final product will be two hydroxy groups are added across the double bond from two different sides. And this is also called an epoxidation reaction, as we are forming an epoxide. So I will see you guys next time.